Hello students, today in Chemistry with Backbenchers we are going to do the topic called Introduction to Electronic Effects. So of course this is the gateway to understand organic reaction and reaction mechanism, as you can see in the title. This is very important. So this is a short introductory class which is not uh, learned in most of the classes. So we'll start with this. The first question which comes is, what is electronic effect, right? What is electronic effect? It's pretty simple. I'll just break the word. It simply means the effect caused by movement of electron, right? Now you should ask me, uh, which types of electrons can be available in a molecule? And we all know in a molecule we can have shared electrons or unshared electrons, right? Shared electrons means either it can be a sigma bond pair or pi bond pair, whereas unshared electron means it can be either lone pair or it can be unpaired electron, which is not shared between two atoms, right? Now the next question which comes, why we are studying this, why movement of electron is so important, right? So I'll give you a simple example. Look at this reaction. So what do we see in this reactions? So in this reaction, so of course you can understand this is a substitution type of reaction where C is replacing B, and you can see here this bond is breaking, AB bond breaks and AC bond is formed. And in other way, if you look at it, what is happening here, you can see, so there is a shared electron pair between A and B, right? Now during the reaction, this shared pair of electron has moved between A and C. So I can say a reaction is nothing but movement of electron. You can also pitch it other way. A reaction is nothing but breaking of old bonds and formation of new bonds. So bond breaking plus bond formation. But we'll learn it in a different way. We'll say that a reaction is nothing but movement of electrons, as you can see here. Now what is the next? The question is, why electronic movement takes place? A simple answer. The answer is to gain more stability. Whatever happening in this world, that is mostly to achieve more stability. Now, of course, the next question I'll ask that how through electronic movement the system can achieve stability. So let us learn how or why. So let's say there is a positive charge and there is a negative charge. We all know that positive charge means it is electron deficit species, right? And negative charge means electron excess species. Now I'll ask you one question. The question is, which species is more stable, charged species or neutral species? The answer is simple. We all know species is more stable. Neutral species is more stable than charged species, right? So that is why mostly whatever is happening, the charged species want to get neutralized. So in that same logic, we can say, yeah, this negative charge and positive charge, both of them want to get neutral, and in order to do that, the electron will move from electron excess side to the deficit side. So one reason for electronic movement can be charge neutralization, which can impart stability. Okay, so there is another question. So let's say in case 1, there are 2 negative charge carried by 1 atom, whereas in the second case these 2 negative charge are distributed between 4 atoms, right? So the question is, which system is more stable? So you can take a pause and think, and then you can again resume the lecture. So the answer is, this system is more stable. Why? You can see that the charge density is less in the second case, where the 2 negative charge is distributed over 4 atoms. So this system is closer to neutrality. So this system is closer to neutrality, and hence this is more stable. So you can see if the charge gets delocalized between different atoms or different places, it will get more stable. So that is another reason of electronic movement. To stabilize the system, the charge can delocalize from one atom to many atoms. So we have got two reasons: charge neutralization and charge delocalization, which can lead to the movement of electrons and by which the system can achieve stability. I hope I am pretty clear. Okay. So far what we have learned is that the reactions are driven by electronic effect or electronic movement. Now here is an interesting thing. What happens in a reaction? In a reaction, we'll simply write we get products from reactants, right? Now you see that here the reactants are classified as substrate and reagent. Now what is the basis of this classification? Okay, so it is based on the reactivity of the reactant. You can see the reactant which is more reactive is called reagent, and the reactant which is less reactive are called substrate. So my question is simple: who will attack whom during the reaction? So of course the more reactive species will attack the less reactive species. That means the reagent will attack the substrate and the bond breaking formation will take place and you will get the product. This part is very important for you through the whole organic chemistry. These reagents, which are more reactive reactant species, they can be classified as electrophile and nucleophile. Now, who are electrophile and who are nucleophile? That lies in the name itself. So, who are electrophile? Electrophiles means simply electron-loving species, right? Those who are looking for electrons, whereas nucleophile means nucleus-loving species. Nucleus means positive charge, right? The species which are looking for positive charge. Now the question is simple: who can be electrophile and who can be nucleophile? Now of course you can say that the electron deficit species, they should be looking for electrons, or the electron excess species, they should be looking for nucleophile or positive charge, right? Now, the point is there is a specific condition to be an electrophile, and that condition is presence of vacant or empty orbital, because the species which will act as an electrophile, that must accommodate the electrons, and for that they need vacant orbital, right? So the electrophile which has vacant orbital, the atom which is in the vacant orbital, that can be neutral, or even the atom which is carrying the vacant orbital, that can be positively charged. I'll give you some simple examples. For example, H plus. We know H plus means there is an empty 1s orbital. So this can act as an electrophile. It is positively charged. If we have carbocations, right? So in carbocations, carbon is sextate. It has an empty p orbital and it has a positive charge. So this can act as electrophile. So these are positively charged. Similarly, if you look at some examples like BF3. So I believe by now we know that trivalent boron has incomplete octet. Technically, it has a sextate, 6 electrons and a vacant orbital. So this has vacant orbital, but this is neutral. So electrophile can be positively charged or neutral, right? Similarly, if I take aluminum chloride, it lies below boron in the same group, group 13, and it is also trivalent and incomplete octet. So it also, and it can act as a neutral electrophile, right? Now, who can be nucleophiles? So, who will be looking for positive charge? Those who have excess electrons or unshared electrons to attack the positive charge, right? And so, the condition for being a nucleophile is the presence of a lone pair. Now, the simple question that which species can have lone pair? So, and the answer is pretty simple. You know non-metals, right? Group 15, 16, 17 elements, they always have lone pair. Like in group 15 nitrogen, it has one lone pair, right? So when nitrogen is trivalent, We'll have one lone pair. In group 16, oxygen has two lone pairs, or sulfur has two lone pairs. They are divalent. And halogens, they are monovalent, and there are three lone pairs. So any species having these atoms can act as nucleophile. For example, so let's say trivalent nitrogen, we have ammonia, we can have primary amine, secondary amine, tertiary amine. So all of them can act as nucleophile. You can take water, just two lone pair in oxygen. You can take alcohol, right? You can take phenol. So all of them can act as nucleophile. You can take H2S, they can act as nucleophile. So one again one. So the atom which is carrying the lone pair can be neutral, or it can be negatively charged. So when it will be neutral and when it will be negatively charged, so when both the electrons of lone pair is of the atom itself, it is neutral. But if between the lone pair one atom is of the atom itself and other has been achieved from outside, so this is an excess electron and you will get a negative charge over there. I hope this is a simple concept we miss, but I hope this is pretty clear here. Also, you can have anionic nucleophiles, for example, OH. So there are three lone pair, it is negatively charged. We can have NH2, so there will be this, right? We can have X minus. There are four lone pairs. I hope you know X means halogen. The foundation of reaction, that is nothing but electronic movement. Now my question is, what is reaction mechanism? What is reaction mechanism? So if reaction means electronic movement or bond breaking and bond formation, then reaction mechanism is simply how the bonds are breaking and how the bonds are forming. That means the path of bond breaking and bond formation, or you can say the path of electronic movement, right? So in the whole organic chemistry, we are going to learn different types of reaction mechanism. So there's various types of reaction mechanism. Why? Because there are different types of electron and different types of electronic movement. So we have to learn different types of electronic effects in order to learn different types of reactions and reactions mechanism. So these are the electronic effects we are going to learn one by one. This is inductive effect or I effect, then resonance followed by mesomeric effect or M effect. There is hyperconjugation, there is electromeric effect. So initially we are going to learn these things. So the next topic which we are going to learn is inductive effect, right? So today we are going to end this class here. So next we'll meet in the inductive effect wala class. Thank you.